What we're going to look at now is we're going to look at something called earth continuity, and that's to ensure that we've got continuity of our earthing from the piece of equipment all the way back through our electrical installation, which is very important. But obviously, as a technician, we're not doing all the way back to obviously the intake position. You're doing it from the piece of equipment actually to the point where you're connecting to, okay? So one of the first things we need to do is select the right equipment. Again, make sure it's a BS or EN. In this case, we've got a multimeter. So with this multimeter, we've got it on the right setting, which is going to be our ohm setting. And then the first thing we need to do is these leads are going to have a resistance in them. So I'm just going to put these together. You'll hear a little bit of a beep, and that's going to give us a resistance reading. And that's giving a reading there of 0.1. Okay, so that's just the resistance of those leads. Once we've got that, we need to write that figure down or remember it. Or some meters will come with an auto null feature, which will just zero those leads so that it doesn't show the resistance in them. But you make sure you do that to start with. So when we perform the test, we're getting the true reading of the earth continuity. So quite a simple test. We've already isolated back at the circuit breaker for this particular isolator here. So this is safe. There's no voltage coming into this at all. We've already done that. So what we're going to do, in this instance, we're going to drop onto the earth within the actual piece of equipment itself. Okay, make sure you're pushing nice on there. And then I'm just going to drop into there. Again, you'll hear an audible beep, and we're just taking a reading. And we've got a reading of 0.2 ohms. Now, like I said earlier, we take off that resistance of the actual leads themselves, 0.1, take away 0.2. In this instance, the maths is nice and easy. We'd end up with an earth continuity of 0.1 ohms, which is a recommended. We can also just check in another couple of places as well, just to make sure. So we could go onto the actual body of the piece of equipment as it's metal, and again, perform the same test. Getting a slightly higher reading this time, but remember we're going through the casing. And something we also do is we can also go to a known earth between the metal casing of this piece of equipment, and you can see here we've got some water pipes, we've got some gas pipes. So again, I could drop onto this piece of equipment here, make sure you get it nice and tight, drop onto this particular water pipe. You can hear an audible beep. Got a reading of 0.04, even onto this gas pipe here, and a bit that's not painted obviously. A slightly higher reading there. But what we're proving there is we've got earth continuity, so in the event of a fault, we know that any fault current is going to travel down to earth safely and not damage the equipment or ultimately electrocute someone.